Hello guys, welcome to the channel. Today we are going to discuss about the famous Monty Hall Riddle that has been asked in the recent SSC examinations. This is a pretty simple concept. You don't have to mug up any formulas to solve this. Once you understand the concept, where you're thorough with it, I think you should be able to solve any question pretty easily. Let us dive into the concept. However, instead of the traditional car and goat example, let us consider a slightly different example in order to make it more entertaining. Let's say you and your girlfriend are in a casino and her father catches you. Instead of thrashing you immediately, he decides to play a game. The game goes like this. There are three doors behind one is your girl. You choose the right door, you get to take her and be happy. If not, behind the other two doors are brothers who are going to thrash you immediately as soon as you choose the wrong door. So it starts like this. You're asked to choose a door initially, and then after that, your girlfriend's father reveals one of the other two doors which has a brother behind that. Now you're left with two choices. One, either to stick to your initial decision, or two, to change your decision and switch to the other door. Usually people think sticking to the initial door is obviously a much better choice, but it's not like that, and you will understand this after watching this video. If you stick to your initial decision, the probability of winning is going to be 33.33%. But let's say you switch the door, the probability of winning is going to be 66.66%. Let's understand how. But before understanding that, let us understand a slightly different concept which will help you in understanding this much more easier. Let us say there are two bags. One has two red balls, three black balls. Let's call this bag number 1 and this is bag number 2. And this has 3 red balls and 5 black balls. If you are given only bag number 1, the probability of choosing a red ball is going to be 2 by 5. If you are given only bag number 2, the probability of choosing a red ball is going to be 3 by 8. But if you're closed, like if your eyes are closed and you are given these two bags, then the probability of getting a red ball from bag number 1 is going to be 1 by 2 into 2 by 5, because you also have to consider the probability of choosing the first bag or the second bag, which is 1 by 2. Similarly, in the case of second bag, if you have to get a red ball from bag number 2, the probability is going to be 1 by 2 into 3 by 8. So if you are if you have understood this, the next concept shouldn't be difficult. Let's dive back into the game. So these are the three doors available to you. You know, one door has your girlfriend behind this. You're asked to choose one door initially. For the sake of convenience for me to explain this, let us say you choose door number 1. Now, of the other two doors available, your girlfriend's father reveals that this has a brother inside. So now you are left with two choices. Either choose the first one or switch your decision and go for this door. But let us consider the initial probabilities of finding your girl behind all of these doors. Just a second, guys. The initial probabilities of finding your girl behind any of these doors is going to be 1 by 3, 1 by 3, 1 by 3. Now, since that you have chosen this door, the first door, the probability of finding your girl behind this is 1 by 3, and behind the other two doors is 2 by 3. Now that your girlfriend's father has already revealed that this has her brother inside, now if you have to, if you were to choose this door and if you have to find the probability of finding a girl behind it, the probability is going to be 2 by 3 into 1, which is going to be 2 by 3, because the probability of this entire lot, the probability of finding a girl behind this entire lot is 2 by 3. And since you are only left with one door to open, since the other door has been revealed, the probability stays the same. I know a few of you have understood and a lot of you haven't understood. So let us consider a slightly different example to make it clearer for you. Let us say there are 5 doors. And you choose the first one. The probability of finding your girl behind this is going to be 1 by 5. And behind this entire lot, it's going to be 4 by 5. Let's say 2 of these doors is revealed with a brother's inside. So now the probability of this entire lot is 4 by 5. But now the two of these are revealed, you only have to choose between either of this. So now the probability is going to be 4 by 5 into 1 by 2, which is going to be 2 by 5, which is still better than sticking to your initial decision. Now that you have understood this, let us solve a few questions in order to make the concept much more clearer. You find yourself on a game show and the host presents you with 4 doors. Behind 3 doors are an assortment of gummy bears. On the remaining door has a pure gold car behind it. You pick a door and then the host reveals a door. Let's say you pick the first door. And then the host reveals a door behind which he knows is only a couple of red gummy bears. Then you are given a choice to stick with your first choice or switch to one of the other two unopened doors. If the probability that you will win the car if you switch is A by B, where A and B are co-prime positive integers, what is A plus B? Now that you have chosen the first one, the probability of winning if you are with this is going to be 1 by 4, and the probability of you winning if you choose this entire lot is going to be 3 by 4. But the host has already revealed this door has gummy bears behind it. So now if you stick to your initial decision, the probability is still going to be 1 by 4. But if you choose this entire lot, since the probability is 3 by 4, and now that you are left with only 2 options, so the probability is now going to be 3 by 4 into 1 by 2, which is 3 by 8, which is obviously better than the initial 25%. So here, since this is A by B, since they asked A plus B, it's going to be 11. Second question. A host places 100 boxes in front of you, one of which contains the Holy Grail. You pick box number 3. So there are 100 boxes. So on. You pick box number 3. Let's say this is box number 3. The host removes all the boxes except 3 and 42, stating that the Holy Grail is in one of these boxes. So the probability of choosing any of this, any of this box is 1 by 100. Since there are 99 other boxes, like if you have already chosen this, and if you choose this entire lot, the probability of you getting the Holy Grail is going to be 99 by 100. But it has been given that except 3 and 42 somewhere here, the host has revealed all the other boxes which do not have the Holy Grail. Now you are left with a choice to stick to the initial decision or switch the door. Now you know that the probability if you stick to your initial door is still going to be 1 by 100. But if you change your decision, the probability is going to be 9900 by 100 into 1, which is 99 by 100. This is because since all the doors are revealed, the probability of switching is going to be equal to the probability of choosing the entire lot, which is 99 by 100, which is basically 99%. In a 10-door Monty Hall variation, the host opens 2 doors. 10-door Monty Hall variation. The host opens 2 doors after your initial choice. Let's say this is your initial choice and he has opened 2 doors. So initially the probability of finding your price in any of these doors is 1 by 10, and if you have this entire lot, it is going to be 9 by 10. The host has already opened 2 doors. So now you have to choose between the remaining 7 unopened doors. Like if you switch to the remaining 7 unopened doors, he's asking what is the probability of winning. So the probability of choosing this entire lot is 9 by 10. But now you are left with only 7 choices. So the probability is going to be 9 by 10 into 1 by 7, which is 9 by 70, which is equal to 12.86%. You can calculate it. In a FIDO version of the Monty Hall game, you pick one door. Let's say you choose this. The host opens one door revealing a goat. Let's say this is the door that is revealed. If you switch to one of the remaining unopened doors, what is your probability of winning the car? So you know, now you've already understood the probability of finding your car behind the first your chosen option is going to be 1 by 5, and the entire lot is going to be 4 by 5. Now that he has already revealed one door behind which there is nothing useful, so you are left with 3 choices. So the probability, since the probability of this entire lot is 4 by 5 and you have to choose one among the 3, the probability is going to be 4 by 15, and if you have to convert this into percentage, it's going to be 400 by 15, which is into 30, 10, 6, somewhere around 26.7 percentage. Thank you guys. I hope you understood the concept pretty well. If not, please mention it in the comments. Even if you have understood, please mention it in the comments. Since this is my first video, I know I've stumbled upon in a few instances. I'll be bringing such amazing maths concepts for you regularly, and I'll be also solving mock tests and also providing you the best solutions for that particular question in a mock test, because in a test usually we are really confused as to which approach to follow. I'll help you in resolving those conflicts, and also if you have any other doubts of any other concepts, please let me know in the comments so that I could make videos on that. Thank you guys. If you like my way of explanation and if you think I could help you guys, please subscribe to this channel, and I'll see you.